From the dawn of history, when humans still lived in the wild and depended entirely on nature, the sky became the very first open book for them to read and learn from. The rising and setting of the sun, the darkness of night giving way to daylight, the waxing and waning of the moon, the stars shifting positions with the seasons, these phenomena sparked one of humanity's oldest questions. What is time, and how does it flow? From that question came the invention of calendars and the birth of astronomy, which over thousands of years became some of the most important achievements driving civilization forward. At first, human needs were very simple. People needed to know when to sow seeds, when to harvest, and when to prepare for floods or the cold season. The moon, with its 29-day waxing and waning cycle, became humanity's first clock. The sun, with its cycle of 4 seasons, gave rise to the concept of a year. The constellations, appearing at fixed times during the year, helped people navigate and predict weather. From these early observations, calendars and astronomy were born, deeply tied to agriculture and religious belief. Among ancient civilizations, each people approached timekeeping and astronomy differently. The ancient Egyptians, living along the Nile, closely tied their agricultural life to astronomy to predict the annual flood. They noticed that the heliacal rising of Sirius coincided with the river's swelling, and from this they created a solar calendar of 365 days, 12 months of 30 days each, plus 5 festival days dedicated to the gods. This was one of the earliest solar calendars in history, used for agriculture, rituals, and administration. However, because it didn't account for the extra 0.25 day each year, it drifted out of sync with the natural cycle, only realigning after 1,460 years, the Sothic cycle. The Egyptians also invented many astronomical tools, such as sundials, water clocks, and the nilometer to track time, monitor farming seasons, and even align temples and pyramids. The calendar was not only a means of managing crops and society, but also a symbol of Pharaoh's power, who was believed to uphold cosmic order. In Mesopotamia, the land between the Tigris and Euphrates rivers, civilizations such as Sumer, Akkad, Assyria, and Babylon thrived. Here, agriculture depended on irrigation, but people still needed calendars to forecast seasons and weather, as well as to manage administration, trade, and religion. The Mesopotamians viewed astronomy as sacred, believing that the movements of the moon, sun, and planets reflected the will of the gods. Unlike Egypt's purely solar calendar, the Babylonians developed a lunisolar calendar with 12 lunar months, about 354 days, and intercalary months to keep it aligned with the solar year. At first, the decision to add leap months was made by kings or priests, but later they discovered the 19-year cycle, with 7 leap years, a remarkably early effort to balance the lunar and solar cycles. The division of the sky into 12 zodiac signs also originated in Babylon, later spreading to Greece and the West. Babylonian astronomical knowledge strongly influenced Greece, Persia, and India, and became the foundation of classical astronomy, echoes of which remain today in astrology and timekeeping. Meanwhile, in ancient China, astronomy and calendrical science developed hand in hand with rice agriculture and political philosophy. The Chinese believed the emperor was the son of heaven, holding the mandate of heaven, so controlling time and issuing calendars was not only for practical use, but also a declaration of supreme authority. They built a sophisticated lunisolar system. A yearly had 12 lunar months, approximately 354 days, but to align it with the solar year, leap months were inserted. The unique aspect was that leap months weren't simply added at fixed intervals, but determined by the Zhongqi 24 solar terms marking the sun's position along the ecliptic. From this came the 24 solar terms, such as beginning of spring, summer solstice, autumn equinox, and winter solstice, directly tied to farming. The Chinese were also the first to record comets, supernovae, and solar eclipses, leaving invaluable data for modern science. Socially, the Chinese calendar regulated farming, religious festivals, and politics, since every new dynasty issued its own calendar to assert legitimacy. The Greeks and Romans took astronomy even further, building full-fledged theories. Ptolemy's geocentric model of the universe and Hipparchus's detailed star catalogue laid the groundwork for classical astronomy. In terms of calendars, Julius Caesar reformed Rome's system, creating the Julian calendar of 365.5 days per year. Later, Pope Gregory XIII refined it in 1582 into the Gregorian calendar, the one the modern world still uses today. During the Middle Ages, the role of preserving knowledge shifted to the Islamic scholars. In Baghdad, Samarkand, and Cordoba, they built great observatories and produced highly accurate astronomical tables. Scholars like al-Battani and al-Sufi translated and expanded on Greek works, eventually transmitting this knowledge back to Europe, setting the stage for the scientific revolution. The 15th to 17th centuries marked a turning point, the astronomical revolution. Nicolaus Copernicus boldly proposed the heliocentric theory, declaring Earth was not the center of the universe. Galileo Galilei, with his telescope, revealed that the moon had mountains and craters, and that Jupiter had moons, evidence against old beliefs. Johannes Kepler formulated his 3 laws of planetary motion, and Isaac Newton's law of universal gravitation provided the physical foundation for modern astronomy. This was when astronomy officially became an experimental science, separating itself from myth and astrology. In the 19th and early 20th centuries, advances in optical telescopes and astrophotography opened a new era of discovery. Humanity identified more planets, nebulae, and galaxies, gaining a clearer understanding of the vast cosmos. Astronomy was no longer just for farming or religion, but essential for navigation, industry, and technology. Today, in the 21st century, calendars and astronomy have reached unprecedented sophistication. The Hubble and James Webb Space Telescopes allow us to peer billions of years back in time, witnessing galaxies from the dawn of the universe. Supercomputers and artificial intelligence now process massive astronomical data sets. Calendars today are merely tools for knowing dates, but are integral to GPS navigation, satellite systems, and atomic clocks accurate down to millionths of a second. Looking back, we see that calendars and astronomy are far more than tools for tracking time or studying the skies. They have shaped human existence itself. Agriculture depended on calendars for survival. Religion and culture were tied to astronomical festivals. Science and technology grew from observing the heavens. And today, everything from smartphones to global navigation relies on the achievements of astronomy. This journey, beginning with notches carved into stone to track the moon, and leading to giant telescopes that reach across billions of light years, reveals humanity's boundless intelligence and ambition. What began as a farmer's need to survive has opened a grand doorway to understanding our place in the cosmos. Calendars and astronomy aren't just about knowing the date, they are living proof of human curiosity, creativity, and our eternal drive to explore the universe.